Now we'll see how easy it is to take over a remote computer. We're in the same local network as the victim. That's why we've managed to bypass the demilitarized zone firewalls of the network that normally block ports. The majority of attacks are local attacks. The attack unfolds as follows. We have a computer that will be the victim. On the attacker's computer, we'll start up the METASPLOIT environment. This framework is automatically installed in the Backtrack 5 Linux. The METASPLOIT framework includes tools for scanning remote computers. The results of the scan will automatically be saved in the database. The specific tool we'll use is Nmap, which we already know. We'll use the information stored in the database to conduct the attack that will exploit vulnerabilities found in other computers that have already been scanned. Let's check to see if we're connected to the database. Right now we're using PostgreSQL. However, other databases, such as MySQL, can be used too. We would like to save the results from the scan in the database. We invoke the db-nmap command. From now on, the basic nmap syntax will be supported. Now we'll examine routes to the computers we're trying to infiltrate. This will help us discover which machines are in the same network as ours and which are 2 or 3 routers away. Because we're discussing the 4th layer of the OSI model, we'll now take some time to discuss the TCP and UDP scanning mechanisms. As the attacker, we would not like to be discovered. Until now, we've avoided this by hiding our IP address among many others. We can also try packet fragmentation. This means to use one packet to send so much data that it can't fit in the frame of a lower layer protocol. A part of this data will be sent in one IP packet and the rest in the next one. This won't affect the delivery because the receiver will assemble the fragments back together into one packet. However, if someone tries to intercept the packets being sent, they may not be able to assemble them. They will not manage to reproduce the whole session. We'll send a 9-byte packet and use the parameter f option to force the packet fragmentation into 8-byte parts. We'll also detect the operating system and perform a stealth scan. Finally, we must type the IP addresses or names of the computers we're going to scan. To make the attack less noticeable, we'll scan the computers one at a time, starting from the first one. We'll use random IP change. This is to deceive intrusion detection systems looking for certain patterns. The information we will scan is identified by IP 192.168.0.115, and the second by IP 192.168.0.125. Below, you can see the complete command executing all of the above operations. We're scanning local network computers, so it shouldn't take much time. Let's look at the result. One host is online. TCP ports 135 and 445 are open. We can see that port 139 is open as well. This information tells us that there's a Windows 2000 or XP operating system running on the computer, because these systems have the above-mentioned ports open by default. Nmap managed to precisely determine the operating system, including the service pack version installed. The computer is only one hop away, which means it belongs to the same local network. Now let's check the data stored in the database. It contains the records about 2 computers. The first one is the result of the scan we've just performed. We can also learn that services are running on these computers. We could list out potential vulnerabilities of these services. Instead of that, let's try to exploit them to conduct an automated attack. The information you can gather from the fourth layer of the OSI model is enough to take control over a remote computer with security issues.